Hi, I'm Henry Segerman. This is a new kind of mechanism or linkage. I call this a branched scissor linkage. So this is this extending, contracting mechanism. It's maybe similar to these sort of cartoon extending arms with a boxing glove on the end of it. So you can extend this outwards and assault somebody from a distance. There we go. So where does this come from? And where does the name come from? So an ordinary scissor linkage looks something like this. So you've got these various sort of cross-shaped pairs of arms, and they link together, and these rhombic shapes in the middle transfer force along from one end to the other. And what's going on here? Well, you'll notice this branched scissor mechanism has inside of it one of these, this ordinary scissor mechanism. But then if I turn this by 90 degrees, you can see there's another one in there as well. So it's sort of two copies of this ordinary scissor mechanism contained inside of the branched version. And so branching is sometimes a thing that shows up in areas of mathematics. The idea is you take something, say this ordinary scissor linkage, that has an axis of symmetry. Right? If I put a line down here, then you can see it's rotationally symmetric. And I can imagine cutting this along next to the axis of symmetry and kind of squishing everything into only half of the full circle, and then taking two copies of what you get and putting them together. And so when I squish it into half of the circle, and rather than these two arms being at 180 degrees from each other, they'd be at 90 degrees, and then I can put the two halves of that together, and then I'll get four arms that are connected together, each at 90 degrees. So this is made from just two pieces. There's this sort of cross piece, which is like a branched rivet, I call this. So instead of the ordinary rivet in a scissor linkage, there's a branched rivet, and then there are arms that connect around and produce the connection up and down the scissor linkage, the branched scissor linkage. So another thing I do is instead of using a four-way branched rivet, I can use a three-way branched rivet. So that's this one over here, same sort of idea, but at each level there are only three arms rather than four. These actually use the same amount of material, or same number of arms. This one is 6 segments each with 4 arms, that's 24, and this is 8 segments each with 3 arms, but same sort of thing. And you could do, instead of 3 or 4, you could go to 5 or 6, or really whatever you want. Now the thing I showed you at the start, I showed you a couple of movies of a larger structure that's made from these kinds of linkages that are connected together and turn corners. So what I'm going to do is take these apart and show you how to connect them together to produce these larger structures. So let me put this one aside for now, and I'll just make this one for now. Okay, so now I've got 4 copies of this much shorter branched scissor mechanism with these 3 arms coming together. And what I'm going to do is I'm going to connect them together sort of at a corner using these extra pieces here. These connectors plug onto the ends of the arms of these, just like that. And so I'll put 2 of these together around one of these little triangles, and then we put another pair of triangles on the end here, and then we'll start to see how these work. Put this in here. Okay, so now I've got a branch scissor linkage up here and another one here, and they're connected together by these 2 triangles, and the effect of this is that when one of them extends, the other is forced to extend as well. And so the reason for this is that when this one extends, then these 2 arms are forced together, and since these 2 little triangles are connected to those arms, these 2 arms are forced together, and that forces that one to also extend. And so we have this ability to make the force transfer turn a corner. So rather than going along here, now it goes off in this direction. And what I'm going to do is I'm going to add on the other ones around here to produce a sort of tetrahedral node. So let me just put this together. Okay, so now it's all together. I've got this structure that collapses down into this little tetrahedral shape. And then, in principle, if I extend one of these things, oops, I'm still a little bit stiff. So when one of these extends, the other three have to extend as well. Let's try that again. Oops. Oof, there we go. Still a little bit stiff. This loosens up with time. So we sometimes call this the triple punch because it's useful for punching three people in the face at the same time. So yeah, this allows you to build larger structures that all expand out and contract together at the same time. So here I've broken down the four-armed scissor linkage into three shorter parts, so each of them with only two segments, and they're connected together with these triangular parts, and it's the same sort of deal. They all extend and contract in principle at the same time. There's a fight between the friction in the hinges and the flexibility of the material, but you can see that it's more or less working, and this gives you three right angles, so this is one of the corners of the cube that I showed at the start of the video. So the real question is, what are the applications of these things? What can these be used for? If you have an idea, please let me know in the comments below. Thanks for watching.